Right. So, good afternoon, everyone. I hope you're all well. It's great to see so many familiar names, if not faces, on the participant list today. I'd like to thank you for joining us at the Net Zero Buildings event that's being hosted by the Scottish Climate Assembly in partnership with the Good Homes Alliance and the Passivhaus Trust. And to make a special thanks to our three guest speakers today, Julian Brooks, Dr. Ruth Saint, and Sarah Lewis, who've joined us to share their expertise in their respective fields this afternoon. My name is McElroy, and I'm a professor in the Department of Architecture at the University of Strathclyde, and I have the pleasure of chairing this event today. I'd like to inform all attendees that the event will be recorded by the Assembly. However, the breakout rooms that will be introduced later on in this session will be free of any recording, so Chatham House rules, there's as much as you want it to be. Time is of the essence, and so it's quite a short programme today. So I'd now like to immediately hand you over to Susie Townend, the Head Secretariat of Scotland's Climate Assembly, to deliver her presentation setting out the context of the Assembly and to outline the recommendations that were produced by members which are impactful to the homes and buildings sector. So over to you, Susie.
Thank you very much indeed, Laurie, and I'll just share my slides now. Just bear with us while they load up. Somehow it seems to be quite slow. Hopefully you can see that now. Yeah? Great. So first of all, what is a assembly and what makes it different to a consultation? Is a demographically representative group of members who are given time and opportunity to learn. Then they deliberate before they make recommendations. Members bring their own lived experience to bear, together with the evidence they hear. This gives their decisions weight and legitimacy. So obviously, it's really important that there are many Scotland, as you can see here. These are the selection criteria that we use to select our members. So what is Scotland's Climate Assembly? It came out of the 2019 Climate Change Act and is embedded in legislation with a mandate to make recommendations to government and parliament and a legal requirement for ministers to respond within 6 months of receiving the Assembly's report. So that really carries particular weight in terms of the relationship between the Assembly and government. The Climate Change Act sets out that the Assembly should consider how to prevent, minimise, remedy or mitigate the effects of climate change. So the remit is pretty wide in scope and includes both mitigation, so how to reduce emissions, and adaptation, how to make the changes necessary to accommodate the climate change effects that we know we will experience, even if we cut emissions dramatically. So I'm going to move on now to let two of our members, Maya, who's a child, and David, who's an adult, give you a brief overview of the Assembly. And I'll let Scott play the video if he can. I'll just stop presenting so that he's able to share his screen, and hopefully you'll be able to see.
Hello, my name is David. I am a 71-year-old retired glass region.
Hi, I'm Maya, I'm 10 and I live in the Highlands.
Older people grew up thinking that climate emergency was something far off into the future. They thought of it at all. It's my reality now. We all have a responsibility to tackle it.
I've never known a time when the climate emergency didn't threaten my future. I can't see a world without it. It's something me and my friends are growing up with.
People from all walks of life were brought together as a mini Scotland to agree how the country needs to change to tackle the climate emergency. We examined the evidence and found common ground on a way forward. Already we are seeing the harmful effects of climate change in Scotland and around the world. Temperature rises, extreme weather, damage to plants and animals under rivers and oceans, threats to our food supply. There is so much waste in how we do things at the moment. That needs to change now. This needs to go much further than just a bit of household recycling. We need immediate action to bring down Scotland's carbon emissions.
It can't just be down to us as individuals. We need everyone to pull together. Government, businesses, and communities across Scotland. We need big changes. Changes to how we work, how we travel, how we build our buildings, how we heat our homes.
We can make big changes right now. Changes to how our public services are run, how we make sure we all understand the climate emergency, how we use our land, how our communities are connected, how our businesses work. We can make a better Scotland by making these changes together.
It's time for Scotland to take the lead in tackling the global climate emergency.
Scotland's Climate Assembly has laid down a mandate from ordinary citizens about immediate action. We can make a difference.
We can make a difference.
Thank you very much indeed. And I'll just try to go back to sharing my slides again. Sorry, we just need to go through to this one. So hopefully you can see that now. So this is a question that members were asked to answer. How should Scotland change to tackle the climate emergency in an effective and fair way? Which you can see built in the concepts both of effectiveness and fairness. I said that members learned from experts as part of the process. The evidence base was balanced and comprehensive, with over 100 speakers presenting to the Assembly over 7 weekends. Members spent some time in 3 streams, one on diet, land use and lifestyle, one which is of particular relevance to this group on homes and communities, and one on travel and work. But obviously they're all integrated and they all came back together to share what they had learned, and all the members, just over 100 of them, voted on the final recommendations and were able to think about the synergies between them. Similar assemblies have happened in other parts of the world, including Denmark, Germany and France, but the involvement of children, including Maya, who you saw in the video, through the work of Children's Parliament has been unique to Scotland. Just over 100 children were selected, with 12 investigators working more intensively. You'll see their calls to action throughout the Assembly report, including sections on housing, where the children said, make sure new houses are built to be environmentally friendly. This would involve making them more energy efficient. And you'll see that the speakers have referenced the children's calls to action in their presentations. The report was laid in Parliament on the 23rd of June. It contained 16 goals and 81 recommendations, and we're now waiting for the Scottish Government to formally respond, and they do have until the end of the year to do so. We won't go through all the recommendations, or indeed all the ones related to housing and building today, but their scope is extensive and in several cases go further than existing policy. For example, on fuel poverty, the recommendation is for the strategy currently in draft to be implemented immediately and the target date brought forward from 2040 to 2030. They're also wide-ranging. For example, we have a recommendation that planning decisions consider climate, but it is set out in terms of carbon sequestration, adaptation. Oh, have I just been thrown out of the meeting?
No, you're in the meeting, Susie, but your slides have just stopped.
Let me just go back.
I don't know what happened.
Sorry, just bear with me now.
No, there are people still coming into the meeting. It just could have been that there was a glitch with someone being...
Can you see my slides?
Not yet.
Okay, sorry, apologies for this.
That's
just,
it. That's you.
And are we back at...
You're at number 1 again, I'm sorry.
Oh dear. How about that? Is
That's
that better now?
Yeah.
Okay, so I think I was just saying that they're pretty extensive, but also quite wide-ranging, and talking about particularly the one on the planning decisions considering climate, which was set out in terms of carbon sequestration, adaptation, biodiversity and well-being, so really quite a holistic approach. And for today's event, we have identified 3 key themes: embodied carbon, the performance gap, and the use of Passivhaus standards. And I'm delighted that we've got 3 excellent speakers to go into those in more detail. I won't go into those recommendations, but I'll pass over to Sarah, Julian and Ruth to cover them in their presentations. And pass back to Laurie now. Let me just stop presenting and hopefully you get the screen back, Laurie.
That's fine. Thanks very much, Susie. And as someone who contributed to the Homes and Communities workshops the Assembly ran last year, while preparing the report, it's great to hear about the developments and outcomes from the innovative work of Scotland's Climate Assembly and the hard work that members have put into developing their recommendations. Now, leading on from the recommendations that we've just heard about, I'd now like to invite our guest speakers to present on the themes introduced by Susie and their pathways to implementation in a bit more depth. There's been a question in the chat about Q&A, and yes, we will be holding a Q&A session once all 3 of these presentations have concluded, but feel free to put any questions you may have in the chat or hold on to them until that session. So I'd now like to introduce our first speaker, Julian Brooks from the Good Homes Alliance. Julian will be speaking about the performance gap, the building performance gap, and he is the Programme Director of the Good Homes Alliance and has spent over 3 decades in the construction industry, working in the private, public and charitable sectors. He's been actively involved in environmental and construction issues since the mid-1990s and has co-authored 2 publications on sustainable construction. He's a qualified BRE Eco Homes and Code for Sustainable Homes assessor and jointly won a CIOB Innovation and Research Award for his work on daylight and sunlight modelling software. He was a CABE, which is now Design Council enabler, and he ran his own built environment, energy, sustainability consultancy. So over to you, Julian.
Thank you, Laurie, and thank you, Susie, for inviting me, and delighted to address the Scottish Climate Assembly. So I'll move on to my slides, and then I'll tell you what I'm going to talk about. So can you see the slides? Just double check. That should be Mind the Gap, the Performance Gap and Building Performance Evaluation front slide. Can you see that?
Yeah. Yeah.
Great, okay. Let's just quickly move to the next slide. Is it working? Yes. So I was asked to talk about the performance gap and the work that we've been doing in England through the Good Homes Alliance, and also to set this within the context of the recommendations for action. And I picked out 3. So hopefully if you haven't seen all these recommendations or can't remember them, I'll remind you. So the first one was Passivhaus standards for new build, which I think got pretty much a unanimous vote. So updating building standards within the next 5 years to Passivhaus standards or an agreed Scottish equivalent. This is a subject dear to my heart. I've certainly discussed this with my board of directors and suggested that we should be moving to a Passivhaus standard in England and leapfrog all those little cul-de-sacs in between now and then, because we know Passivhaus works. So that's thumbs up to you for going for Passivhaus. And our knowledge of Passivhaus is that it normally reduces the performance gap to a plus or minus 5%. So in terms of doing what it is meant to do, it does. So why wouldn't you use it? The second contextual point would be the new environmental impact assessments, which got a 90% vote. And this is to basically put together a new way of assessing existing and new homes, which adapts SAP and EPCs to measure all aspects of sustainability, which is, again, big thumbs up from us. SAPs, EPCs at the moment are full of holes. floors. You know, they were there to do a particular job, which they've managed to do for quite a few years. But in terms of their accuracy, very poor. So we again we're actually asking English government to revise SAPs and EPCs with some success, and there is we've had some presentations from them about what they're planning to do. And you've also linked it to assessing council tax bans. Now that's very interesting because we're trying to get them to link it to stamp duty land tax bans, effectively. So the more efficient the building, the less stamp duty you pay. But council tax is another way of doing it. So that's got the thumbs up. But we do believe that actual energy performance is the critical factor here, and disclosure of it post occupancy. So actual energy performance compared to predicted is a metric we've been lobbying for in England, and I'm sure you've talked about that as well. The third point, planning decisions consider climate. So local authorities and their planning departments and their planning policy teams must ensure that carbon is dealt with. But the bit that I picked out of this was well-being. All too often, well-being is seen as a kind of urban design, green infrastructure, blue infrastructure, call it what you will. But actually, we're very, very focused on the well-being of the occupants. Building regulations shouldn't just be about the health of the building, it should be about the health of the occupants as well. So I've picked that out as occupant health must be included. I will now move on to telling you about us, and then a little bit about the performance gap. So who are we? Well, we are a not-for-profit community interest company with a membership of about 82 members. We've been going now for 14 years. We were set up to promote quality, sustainable homes, communities for a healthier, low-carbon future. We carry out research, original research, primary research. We do training. We run campaigns. We walk around Bristol with banners. There's a picture of me and my vice chair, Mike Roberts. I think that was 2 years ago now. And we have a network, 2 networks, critical networks, I would argue. They were formed during my time, the last 5 years at the GHA, and they are for local authorities and housing associations. The local authorities are in the Vanguard network, the housing associations are in the Pathfinder network. They don't generally meet together because they have slightly different agendas. However, both of them have a common agenda, and that is to go net zero with their new social housing as quickly as they possibly can. And we've formed these networks in order to share knowledge, experience, bring expertise together to enable them to do that. And they're proving very popular. We've got over 30 members now, and it's growing all the time. And there's no reason why you couldn't have something very similar. In fact, you probably do have something very similar in Scotland. We're just waiting on Welsh Government, who we've been working with around the net zero agenda. We're waiting for them to set up the Welsh Low Carbon Hub, or Zero Carbon Hub. The name isn't agreed yet. And once that's formed, the aim and the focus will be the social housing sector. All local authorities and housing associations will work with the hub to produce net zero new homes. We're also part of the Sustainable Development Foundation Alliance of Organisations, that's SDF, and I'll talk a little bit about them later. So what is the performance gap? So the performance gap is normally defined, in fact I've not seen any other descriptions of it, it's the difference between the predicted performance, the energy performance of the building, not just energy but environmental performance, at the design stage and then how the building actually performs once it's completed and in use. And it can vary. This is using SAP and building regulations. There was research carried out, well, lots of research has been carried out in this area over the last sort of 15 years. It can extend from 50% through to 150%, this difference between predicted and actual. And what it shows is that the SAP and EPC system is really there for compliance and nothing else. It does not bear any relationship to the actual performance of the building itself, whether it's the cost to run it or whether it's the environmental standards and the performance, whether it be air tightness in use, whether it be the ventilation rates, whether it be thermal bridging, whether it be the energy required, the primary energy to heat the building. They just don't, you know, they're miles apart. The only point I would admit to, and we have admitted to, is that there is within the SAP system, within the energy prediction system, a primary heating demand figure, which doesn't get used in the EPC, but it is within the SAP software, and that actually isn't a bad representation normally between predicted and in use, but it doesn't get used. So it's a bit of a flawed process. However, the industry uses it, the industry's got used to it, and we're stuck with it for the time being. So is it just about energy? No, it's not. And as I said earlier, it's about the occupant comfort issues, whether it's temperature, drafts, humidity, overheating, whether it's about the indoor air quality, the amount of fresh air changes, CO2 levels, moisture. I believe in Scotland, building regs, you've had CO2 monitors actually installed in new homes. Correct me please if I'm wrong, but I think you have. So you're actually already in advance of some of these issues and fully aware of them. Why does it occur? Okay, poor design, modelling, inaccurate occupant behaviour assumptions. Now there's a lot in that statement, probably not worth unpicking too much of it now. Maybe we can do that in the workshop. Poor workmanship and on-site practice, age-old problem. A lot of trades, a lot of coordination, and not always well managed. Substitution of materials from those originally specified. They used to call that value engineering when I was in that business, but actually it's more than that. It's a lot of the time you are getting a cheaper product with a poorer performance. Insufficient inspection and on-site verification, a lack of police on site, the building police effectively. And I don't know what it's like in Scotland, but certainly in England, that particular discipline has been sort of pared down, hollowed out over the years, and there aren't enough people on site doing that checking. And then contractors and training for them so that they can understand the importance of these details. Age-old problem. Some contractors are too busy to let their operatives be let off for the day to go and do some training. But we can discuss that more fully in the workshop. Lack of understanding of building standards and requirements, says it all. And then inadequate installation and commissioning of services. In commercial buildings, non-residential, there's a lot of emphasis on the commissioning of services because they will be held to account by the occupants or the owners, the long-term owners of those buildings. That doesn't happen so much with new build housing, if at all, really, especially if it's being sold. Once it's being sold, NHBC or the warranty provider comes in, provides an insurance service on defects. That some things are obviously not covered, but most are. And the house builder walks away to the next project. So sometimes there isn't any incentive for that to happen. But where there is incentive, of course, is with affordable housing, social housing. How are we doing on time, Laurie?
I'm not sure. Where are we? 13:28. You're a wee bit over time, but you're not really, because we were a wee bit late in starting, so you've got a few minutes.
I'll rattle through. So, how can we close this performance gap? Well, there's lots of studies on this, and there are lots of tools. Well, I say lots. There are tools. Passivhaus will help massively because it's such a robust process. So you've already picked Passivhaus out, which is great. So you're already more than halfway there. Building Performance Evaluation, or BPE. Now that's a term you're going to hear more and more of with our journey to net zero new housing. I think there's going to be a new discipline. So for those of you out there thinking about what to do in the future as a vocation, and you're interested in buildings, I think there's scope here for a building performance evaluation assessor or evaluator. And there will be some courses coming up. One of the places to watch would be the University of Sheffield, where Professor Fiona Stevenson works. But hopefully, Strathclyde might be doing something. They've got some good people there. So BPE, look out for that. There'll be a new British standard on this as well, 40101. It's due to come out early next year. Quality assurance methodologies. There's a couple around. One was developed by Bioregional called BEPIT, which is worth checking out. It's got an interesting little acronym. I won't go into what it stands for because I can't remember. And the other one is the Assured Performance Process. Now that's something that we're involved with the National Energy Foundation. So look out for that next year. I'll talk about that in a minute. And then testing and verification. So the air tightness testing, coheating, indoor air quality testing, all of that will have to take place. We've developed some model employers requirements around this. They're available for free from our website. What do homeowners want? Well, as these homes don't perform as they were predicted to, it does leave homeowners with this issue. Generally, though, they don't have a clue about these performance gap issues. It's not something that the estate agents or the sales office of the house builder are going to tell you about. So there is an issue about education of homeowners, and that's something that still needs to be done. Maybe the Climate Assembly wants to look at education around those issues. So it needs to be demanded by buyers. And then we did some survey work with Design Council. We're involved. And it picked up on what most matters, and it's homes that are comfortable and easy and affordable to run and maintain. A no-brainer, really. But the performance gap doesn't provide that. So it makes those things harder to attain. So we've also got some guidance coming to the end now. So these are all free off our website. And we did some work with some of our Welsh colleagues, and that's the picture you see on the right there, the Homegrown Homes project, which is a fascinating project. In there, lots and lots of information about building performance evaluation. As a go-to guide, it's again a no-brainer. Start there, and you will succeed if you start there. There's a lot of really good stuff in there. We've also been doing some State of the Nation review work on performance evaluation of new homes, and some shocking results are in that, so that's also available. I mentioned the British Standard, and I've mentioned the training that's needed. So we're working with the Building Performance Network to create some online training materials for building performance evaluation and QA. So look out for that. It's not ready yet. Maybe next year in the summer we'll have something available. The Assured Performance process is a very robust, thorough process. Goes from early design stage all the way through to completion and beyond. And this is a tool effectively designed to eradicate the performance gap. And that will be relaunching next year. So in terms of getting involved with us, we haven't done any work specifically in Scotland. That's not because it we don't want to, but it's because I don't think we've managed to sort of get enough interest about what we do in Scotland. But if there was, we would. And if we could work with a local organisation like SECA, I think they are called, which is an architectural ecological organisation, we would work with you and try and bring all this to you if you needed it. And we rely on members and subscriptions, and we rely on funding for research and training. So it's all there, all available to you there, a lot of it on the website. I'll quickly
Julian,
mention this.
We're really running over time now. So
Sorry.
No, it's fine. Just as quickly as you can.
Yeah,
okay.
Well, we've just been recognised through our alliance with the Sustainable Development Foundation by the UN. So we've now got UN accreditation as a centre of excellence for high performance buildings. And there's the signing ceremony at COP26. I will move on, I think. Thank you. Thank you very much, and I look forward to seeing you in the workshop. Thank you, Laurie.
Thanks very much, Julian. Sorry for cutting you off there. It's just such a tight programme today, but I'm sure a lot of these points you'll be able to pick up on in the workshop. There's some big challenges in there, not just for the workshops. I'm particularly interested in issues around the inaccurate occupant behaviour modelling and the value engineering issues that you threw up. And incidentally, Scottish Government is currently consulting on increasing site supervision and compliance checking, particularly for housing. So just something else you could maybe pick up on.
Thank you.
So we'll move swiftly on. Our next speaker is Dr. Ruth Saint, who's speaking on the topic of embodied carbon. She has an academic background in environmental geoscience and has recently completed her PhD in the thermal performance and environmental sustainability of a novel solar water heater design. She's also passionate about climate change mitigation and wider, more holistic sustainability issues. And taking the research and skills gained throughout her academic career, Ruth has co-founded Building Research Solutions, a company dedicated to bringing academic rigour to industry, providing science-based solutions from sustainable design to building performance and sustainable communities. So whenever you're ready, Ruth, over to you.
Thank you. I'll just share my screen. Can everybody see that okay?
Yeah, and I'm noting that you're starting at 13:36, so you'll get your full time.
Okay. Hello, everyone. Thank you for the introduction and for inviting me to speak today. So as Laurie said, my name is Ruth Saint, and I'm the Operations Director at Building Research Solutions, as well as the leader of our Sustainable Design theme. I've also recently started a research fellowship at Edinburgh Napier University, looking into the sustainable design and construction of post-disaster, post-conflict sheltering for refugees. So I'm going to be talking about embodied carbon in construction, highlighting the Climate Assembly recommendations and how the construction industry can help support those goals. So I'll start with a brief description of embodied carbon and how it fits in the context of construction and a building's life cycle. Then I'll talk about the current context of emissions in the construction industry and the contribution of embodied carbon. I'll then highlight the Climate Assembly recommendations related to embodied carbon and how the construction industry can support these recommendations to achieve the goals. So, what is embodied carbon? Say you get a new phone. The main things you're thinking about are probably how much that phone is going to cost you to run, for charging and bills, etc., how long you're going to keep it for. You're probably not thinking about all the energy and materials that have been spent to make the phone in your hand, and the environmental impacts associated with production of that energy, and the mining, extracting, processing, and transport of the materials that are needed to make the phone, as they are embodied in the product itself. So when that phone leaves the shop shelf and goes home with you, there is a long trail of impacts left in its wake, and these are known as embodied impacts. So to make that phone, there is a hidden environmental price that people often don't think about. In terms of embodied impacts in the construction of buildings, there is a British standard that is all about the sustainability of construction works and offers a calculation method for the assessment of environmental performance of buildings. And the graphic here shows the life cycle stages specific to buildings and construction products, as defined in this standard. So stage A1 to 5, the product and construction processes stages, shown here, occur before the building is in use. Stage B is the use phase and is where the operational emissions occur. Stage C is the end of life stage, where the building and its components get deconstructed or demolished. Stage D is a supplementary stage to the life cycle and considers reuse, recovery, and recycling potential, including the benefits associated with keeping materials in the resource loop, which is where design for disassembly or demountability is very important. So, of these life cycle stages, only stage B1, B6, and B7 refer to operational. The majority of the life cycle falls under embodied impacts of the building. So these are some of the climate assembly recommendations related to embodied carbon. I'm not going to read them out, but basically the recommendations to achieve the first goal around quality standards of EnerPHit and Passivhaus design, which Sarah will talk about after me. Those recommendations are around the building standards regulations and include whole life assessments, including embodied and operational impacts, and design being driven by end-of-life reusability and recyclability through design for deconstruction. The second goal here, around retrofitting Scotland's existing building stock, includes recommendations to retrofit all homes and decarbonise by 2030. In terms of the first goal and whole life assessments when designing to Passivhaus and EnerPHit standards, this is really important because the built environment is responsible for approximately 45% of CO2 emissions from the energy consumption of residential homes and commercial properties for space and water heating, cooling, lighting, etc. So the operational emissions. And Passivhaus and EnerPHit standards aim to significantly improve the operational efficiency of homes, thus driving down its demand. Alongside this, though, as you drive down operational emissions, the proportional contribution of embodied emissions get bigger. So the stats shown here give an indication of this shift, with the embodied carbon contribution to the whole life cycle impacts being between 11 and 13% for passive designs, which is not necessarily the same as Passivhaus standard, and as much as 100% for near zero energy buildings, which is where the definition only considers operational energy and the energy supply is largely from renewable sources. So it's very important that materials and technologies are selected carefully, considering source of supply and logistics, that the energy efficiency of construction practices is increased and optimized, that embodied impacts are considered as early as possible in the design stage, and that design for deconstruction is implemented. It's also really important to bring everyone involved in the design to the table at the very start in order to choose a well-balanced, fit-for-purpose solution. So to give a better understanding of the relationship between embodied and operational energy, or carbon, this graphic outlines 3 types of relationship. So no link, direct proportionality, and inverse proportionality. For type 1, there is no link between embodied and operational carbon. For example, a smaller versus a larger steel beam in a building. So the larger beam will incur more embodied carbon because it's bigger, but it does not offer any additional operational energy and therefore carbon reduction benefits. If the smaller beam is able to provide all the structural requirements and fulfills the same function, obviously you would choose that one. Otherwise, you're over-engineering for the sake of it, essentially wasting carbon and probably increasing costs. For type 2, where there is a direct proportionality relationship, we have an example of a timber window frame versus a steel window frame. So the timber has a lower U value than the steel frame, i.e. it loses heat more slowly, so it contributes towards lower operational emissions as there's less heat loss, but it also has a lower embodied carbon impact because the raw material extraction and processing is less energy intensive. Also, you have the added benefit that the timber acts as a carbon store throughout its useful life as trees absorb CO2. So the obvious choice here is a timber frame, as you benefit twice, greater thermal performance and lower embodied impacts. Now type 3, inverse proportionality, this one is a tricky one. So let's say we wrap a building with extra insulation, and that creates a spike in the embodied carbon today, right now, as we're paying this upfront embodied carbon cost to have operational energy demand reduction across the next however many years. So this insulation is being added while our energy grid is still relatively carbon intensive. We still rely heavily on natural gas, which emits about 0.18 to 0.2 kilograms CO2 equivalent per kilowatt hour of energy, and we're still a ways away from fully decarbonizing electricity, which is sitting at around 0.23 kilograms CO2 equivalent per kilowatt hour. So while the energy grid is still carbon intensive, the embodied impacts associated with the processing, manufacturing, and transporting that material can be high, depending on what material it is and where it's made. However, its immediate benefit will also be quite noticeable, as you're reducing demand while the energy supply is still carbonized. However, applying the insulation based only on this immediate benefit is misleading, because we would be neglecting the spike in embodied carbon, so our upfront carbon cost. and people, much more often than not, do neglect the embodied carbon. So we start with an embodied carbon premium that we've accepted to pay to have the insulation in the building. Every year that the insulation reduces the energy demand of the building, we pay back a little bit of that premium. And only once that premium has been paid off do we start to see a net carbon benefit from adding that insulation. So for the first however many months or years, the insulation is not reducing carbon emissions, it is simply repaying its own embodied carbon. Also, as we get ever closer toward decarbonising the grid and moving away from natural gas for space and water heating, this payback will get smaller and smaller, and it will take a lot longer to repay that embodied carbon capital cost with the carbon savings from our reduced energy use. So the same applies to any retrofit measure you add to a building, and the question is, if we carry out retrofit at scale, will it pay itself off? When does it pay itself off? With the ambitious recommendations laid out in the Climate Assembly report to retrofit all Scottish homes by 2030 to be net zero, given the 2.6 million homes in Scotland that need some form of retrofit, this means retrofitting approximately 1,400 homes per day. And given the climate crisis we're in now, can we afford to spend that carbon premium and have that embodied carbon spike? Or will it be too late by the time it pays itself off? So by the time it actually becomes net zero? And this is just Scotland. So what if this was scaled globally? How can anything be truly net zero if we don't consider the embodied impacts? You're neglecting the majority of the building or product life cycle. So we need to think very carefully about our building stock and make smart carbon investments today, considering the whole life cycle impacts, not just operational, and future-proofing the decisions we make as best we can. Now, I'm not advocating against retrofit at all. Strong measures do need to be taken, and something needs to be done to address the climate crisis. What I am advocating for is that embodied emissions are seriously brought into the conversation, and that they are at the forefront throughout all stages of building or retrofit projects. And embodied emissions need to be balanced against operational savings, considering the future of our energy landscape. So if anyone wants to read more about this, there are 3 great documents from LETI. So the Climate Emergency Design Guide lays out a strategy for new builds, and linked to this is the Embodied Carbon Primer, which is an excellent document that allows people who are not familiar with the topic of embodied carbon to get a good understanding of it. Also, the Climate Emergency Retrofit Guide for existing buildings, which are more problematic as you don't have the freedom you do with new build. You have to work with what is already there. It's very useful and offers a quick start guide to help you set appropriate targets and identify the best approach. It also offers a holistic view of sustainability and allows you to make a case for retrofit based on environmental, economic, and social factors. So with that, I'll end on the reminder that although carbon is a hot topic at the moment and a very pressing issue, climate change is not the only environmental issue facing us. There are numerous other environmental factors to consider, and by focusing solely on carbon, we risk shifting the problem onto other areas of damage. To be truly sustainable, we need to balance holistic environmental impacts, weighing the benefit and harm across all environmental indicators, balance that with social and economic factors. Especially given the scale of the issues we're facing, we need a multidisciplinary approach, and we need to get it right the first time. Thank you.
Thank you very much, Ruth, for some interesting insights on embodied carbon. It's good to hear that the Assembly is on the case here, and particularly interested to see your insights into the impacts when whole life carbon is taken into account on things like retrofit. And thanks also for keeping to time. I mentioned that the LETI documents are available online in the chat, and I didn't have the web address to hand, but I'll stick that in the chat in the next few minutes. So we'll just move on now to hear from our final speaker, Sarah, who will be presenting on the topic of passive house and retrofit to the equivalent inner fit standard. Sarah is the Research and Policy Director of the Passivhaus Trust and has delivered and worked on some of the UK's largest passive house developments. She has received many accolades in recognition of her contributions to UK low energy architecture, including the 2018 European Sustainability and Environmental Woman of the Year and Constructing Excellence Achiever of the Year in 2015. In 2013, she was listed by the HA as one of the top 20 women leading the way in sustainable architecture in the UK. And she's also the author of the best-selling RIBA book, PHPP Illustrated, written for all architects hoping to design the Passive House standard, and she regularly lectures on the evolving zero carbon standards. So over to you, Sarah, other than I will share your slides on my screen, and hopefully that'll work for us all.
Thank you, Laurie. Thank you for that introduction. Thank you, Ruth and Julian, for those presentations. It was really excellent. It's always wonderful to hear people speaking on this topic that's so important. So as Laurie said, I'm Sarah Lewis, Research and Policy Director at the Passivhaus Trust, and we are delighted to be contributing to the event today. I'm actually casting today from the SEC in Glasgow, where I'm giving a presentation shortly on the UK's first school aiming for the full Passive House retrofit standard, which is the NRFIT standard. And that school's in Galston, not far from where we are. So yes, and I can also endorse that document Ruth was showing, the Letty retrofit guide, because the Passivhaus Trust actually co-authored that document. So it's a really good read, and I do recommend it to everyone today. Next slide, Laurie. Thinking about it. Okay, so there we go. Click on. Thank you. Click once. Thank you. So I'm just going to start today, and I'll just, after introducing very briefly the trust, I'll talk through some of the assembly recommendations. Click on. Then I'll look at the kind of fits into the zero carbon big picture, and I'll finish with an introduction to Passive House and NRFIT. Next slide. So the Passivhaus Trust is an independent organisation. It's a non-profit, and it provides leadership in the UK for the adoption of the Passive House standard and methodology. And we are very much a UK-wide organisation with representation across the country. I'm based just east of Edinburgh in Scotland as well. And our aim is very much to promote the principles of Passive House as a highly effective way of reducing energy use and carbon emissions in the buildings in the UK, as well as providing these really high standards of comfort and building health, which is so important as well. Next slide. So we pulled out this, it's thinking about it again.
It's not happy.
Well, I'll just go through it because it's just the other way.
Here we go.
Oh, perfect. So this was one of the sort of high overriding recommendations from the Assembly, which we pulled out because it's talking about setting NRFIT, which is the retrofit standard, for Passive House Classic, which is the new build standard, as a really a minimum for both domestic and non-domestic buildings in Scotland going forward, which is something we wholeheartedly support. If you go on to the next slide. I've just pulled out these three sections. So there was a 97%, I think almost universally on all these Passive House points, but this one was that all new housing should be built to the Passive House standard or equivalent within the next 5 years. Next slide. That there should be a plan developed across Scotland to enable the retrofitting of homes by 2030, and that non-residential buildings also should apply either NRFIT for retrofit or Passive House standards or equivalent within the next 5 years. Next slide. So I'll just go on just to give a little bit of a detail of how that kind of fits into the net zero picture. I should say, just while I'm on, that the Scottish building regulations are going through a consultation at the moment about what the future standards are going to be. And I do recommend people respond to that consultation. It closes on Friday. And if you want to see a draft of what the Passivhaus Trust will be publishing, if you want to use that as part of your response, I can provide that for you. It will be going up on social media at some point later today. Okay, so next, thank you. The IPCC identified this CO2 pathway that we need to follow to get to net zero, and that's the red line. Now, that's very steep, and it's actually steeper than the route that we took to get to where we are today, which is the green line. So we can't, therefore, spend the next 10 years waiting on technology solutions or consulting on policy. It's like act now. It's the point we're at in the crisis. Next slide. And when we look at how our buildings fit into this picture, they contribute about 27% of emissions, and 18% alone come from our homes. So it's a major part of the footprint. And also, we know that the majority of our buildings are pretty wasteful and inefficient. So critically, buildings are this area where really significant savings could be made. Next slide. So this chart is looking at the energy performance certificates which were lodged for all new dwellings in the UK over the decade 2009 to 2019. And shockingly, we see almost a complete flat line in terms of energy improvements. So in effect, we have this lost decade in our fight against climate change in our sector. Next slide. And then it should come as no surprise that when we look at the UK greenhouse gas emissions from our buildings, this too shows no discernible improvement over the last decade. Next slide. And as the grid is decarbonised, Ruth actually kind of pointed to this, there's this increasing case for us to use more electricity for heating purposes. So we need to move our homes from the high carbon gas onto the electricity, which means that the heating loads which were previously satisfied by gas are going to need to be met by our electricity grid. Now, the gas is showing of our existing homes, just for heating and hot water. That's the orange and the turquoise bar, and this is the peak load, so the peak times, that's what we're drawing. And you can see in the blue what the electricity grid capacity is in 2019, predicted for 2030, and even predicted for 2050. So we see that demand reduction is going to have to be a part of the solution to the problem. And another thing to point out is that, if we don't retrofit our buildings, we don't make them more efficient, of course there's an embodied carbon to doing that, which Ruth was pointing out, but there's also a huge embodied carbon impact to having to build a huge amount of infrastructure and lots of new renewable technology, lots of wind turbines and technology to supply that demand otherwise. So we do also have to consider that when we look at that really big holistic picture. Next slide. So when I talk about demand response, that's essentially this idea that not everything needs to be supplied to us all the time. Not everything needs to be on all the time. So we could use this sort of demand response in a domestic house. And more specifically, if we look at the biggest energy demand in our homes, that's our space heating, we can see what this would do to a typical UK home. Next slide. So on the left axis and the red line, you can see the internal temperature, while on the right axis and the blue line are showing the heating energy power being used by the home. And you can see that in a typical home with an internal temperature, it's going to drop off when the heating's not on, down to about 15 degrees. So we're going to need to inject that heat to get the temperature up when we want it, in the morning or in the evening when we're using our home. And actually right now, a lot more common throughout the day when we're working from home. So by contrast, next slide, a passive house home effectively can take that heat at any time. So it's a much more flexible asset in that sense. So in the traditional house, if you'd load shifted the demand to less peak times, your house would not have been warm when you wanted it to be. But a passive house is this flexible asset, and it can load shift to support the demand on the grid. So the bottom line is that for demand response to work for a domestic building, we need to have a very efficient fabric to start off with. And then we can maintain this very comfortable internal temperature without any impact on the occupants. Next slide. So an argument you hear a lot is that passive house and very low energy buildings are just too expensive. But actually, we had a look at the big picture and compared the cost of building more efficiently over the lifetime of a building, here we've taken 60 years, with the alternative of producing more energy. So that's building more infrastructure. And we can see that the cost at 3 or 4 pence per kilowatt hour saved for building more efficiently, while the cost of generating that kilowatt is more expensive than saving it in every scenario for all forms of renewable energy. So saving kilowatt is going to cost us as a country less than generating. Next slide. So I'm just going to spend the last couple of minutes just running through a kind of very brief introduction to passive house and EnerPHit, although I think a lot of people on the call will already be fairly familiar with the standard. Next slide. So Passive House is this leading international energy standard. I'm just going to pull out a couple of these elements to give you an idea of the breadth of the standard. I've managed to lose the presentation on the screen. I don't know whether everybody else has. It's still working. I'm now seeing like the Chrome window. I'll see it again now. Yeah. So you can just go on to the next slide. So this is the next. So the next slide is very much a kind of classic slide that we use when we talk about low energy and passive house buildings. So the active approach is the coffee on the right. The active approach is on the left, and the right is the passive approach. So typical buildings like that hot plate coffee machine with an uninsulated glass jug, you lose lots of energy in a building that would be through the walls, the roof, the floor, and the windows. So lots of active heating is needed to keep the building comfortable. Whereas a passive building, by contrast, is much more like a thermos, with the heat loss reduced to this minimum amount, so that the additional heat required is kept to a very minimum to maintain this comfortable temperature. Next slide. And this slide and the next one are going to compare a regular building with a passive house. So this is looking at the losses on the left and the gains on the right. You can see that even with the solar gains on the right, which are kind of the browny color, and the turquoise, those are those gains, those are the free heat from the internal gains in the house, like people and cooking. The heating system, which is the pink, has to do a huge amount of work just to keep up with the losses through the building fabric. If you click on, and that's also 60% more than we would have calculated during design, just on space heating, because of that performance gap Julian was talking about. I'm not going to linger on that though, because I'm probably running out of time. But next slide is going to show us the passive house. So you can see that the fundamental principle of passive house is to reduce those heat losses so significantly that the building's heat demand can largely be met then by the sun and the internal machinery, with just this really small contribution by the heating system. And a huge advantage of passive house is we know that it pretty much eliminates the performance gap and has a tried and tested methodology with built examples covering a huge variety of typologies around the UK. There's also this very clear and established training program in place which covers designers, contractors and consultants. And actually Construction Scotland Innovation Centre is running a really good program helping train up lots of contractors at the moment. Next slide. So let's just say there's no performance gap. Mind the gaps, that's what Julian was saying, so I don't need to linger on that. But on average, from monitoring, we know that the existing performance gap in new build homes is around 60% more space heat demand than designed, which is quite shocking. Next slide. So finally, a passive house is not asking us to radically rethink how we construct buildings. It simply requires us to do what we already do, but just do it a little bit, well, actually quite a bit better, with more quality control throughout the design and construction stages, eliminating that performance gap in the process. Next slide. And while passive house is often assumed to be primarily an energy standard, it does do that so well, but it as well has loads of other benefits in terms of health and well-being, performance, finance, and broader societal effects. And a passive house building will result in a much more comfortable building throughout the year with spaces that are healthy to be in. And when we look at the alternative scenarios so common in millions of buildings in the UK, with uncomfortable, unhealthy buildings pushing people into fuel poverty and creating these measurable negative impacts on people's long-term physical health, passive house really becomes a no-brainer. Next slide. I'm trying to let the last two slides. Oh, I lost it.
It's gone again.
It's fine. You know what, Laurie? There was only two, so I'm just going to say that the next slide was just saying that 80% of the buildings that we're going to be looking at in 2045 already exist today. So we have to do something about our existing buildings to be able to have a decarbonized strategy that works within the peak demand limits of our grid. And then that's fine. That was the graph. But next slide, it's fine. And this is just a quote that we really like from National Grid, so you don't even have to show it because I can just say it. But energy efficiency is a no regrets measure for all scenarios. So that's, I'm just going to conclude on that, and we can continue the discussions when we go into the breakouts.
Okay, sorry about a couple of technical glitches there. I don't know why they happened, but thank you very much, Sarah, for that very informative and interesting presentation.